Good morning, everyone. Welcome to Tuesday, April 21st. And today we're going to be doing a quick review of what we learned yesterday about factoring special cases. So we're going to start off with a quick review of difference of two squares. I have the formula on the left. We'll go over an example on the right, and then we'll do the same thing for a perfect square trinomial. After that, we'll go over one of the worksheet problems that you had a question on from yesterday. And then we'll end up with going through IXL problems for your IXL code today. So what we learned first yesterday, we learned about something called a difference of two squares. A difference of two squares, if you remember in the name, it actually tells you what you're looking at. Difference means, is it subtraction? So in this example, I have a squared minus b squared. Subtraction, yes, it's minus, so it would be considered a difference. So that's the first thing. Is it a difference? Yes. Difference of two. Two is telling you the number of terms it has to have. Does this expression have two terms? Yes. And then the last part is the most important part. Are both terms perfect squares? Is a squared a perfect squared? Meaning, could there be a square where the area of that square is a squared? Yeah, because what's the square root? What times what is a squared? A times a. What times what is b squared? B times b. So if it satisfies all three, then you don't have to do the long process of putting in a zero term and doing P's and Q's and so on and so forth. All you have to do is take the square root of the first term and the square root of the second term, and it will always end up looking like this. So where do these come from? Well, by taking the square root of the first term, the square root of a squared is a, because a times a is a squared, and that turns out to be your first term in both of your binomials. The square root of the second term, square root of b squared, what times what is b squared? B times b, that turns out to be the second term. And then if you remember, because there's no middle term, there is no middle term, that means that middle term is zero. One of these has to be positive and one of them has to be negative because they have to add up to zero, okay? So that's kind of the structure of a difference of two squares. Now let's look at an example and see if we can do the same thing. So just off the top of my head, if you're coming up with an example, you have to think about the perfect squares. The perfect squares are 1, 4, 9, 16, 25, blah, 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 blah. So if I'm thinking off the top of my head, I'm going to go with 49. Oops, that's 4a. 49, because that's a perfect square. And I'll say x squared minus, we'll do, I don't know, 64? Sure, let's do 64. That's a perfect square, okay? So 49x squared minus 64. Go through all three checkpoints. Is it a difference? Check one, yes. Does it have two terms? Check two, yes. Are both terms perfect squares? Check three, yes. So it takes one step to factor this. I'm going to set up my two binomials, and to find the terms of my binomials, I just take the square root of the first term. What is the square root of 49? 7. And what's the square root of x squared? X. So this would be 7x times 7x. That's how you get 49x squared. Then I take the square root of the second term. What times what is 64? 8 times 8. So this is going to be 8 and 8. Now, there is no middle term. This is a binomial. There's no a single x term. So that means that is a 0. So how do I get 0 using two 8s? I make one of them positive and one of them negative. And that is how you factor a difference of two squares. We're going to go over additional examples later on in the video, but for now, we're going to go into perfect square trinomials and then additional examples later on. Okay, let's do the same type of review, this time for perfect square trinomials. So in this case, we are looking for a trinomial, meaning it has to have three terms. The first and the last term are perfect squares, and the middle term is the weird one. The middle term is basically, if you multiply the square root of the first and the last and add them together, or in other words, double it, that's what the middle term is. So the structure for this is a little bit different. First of all, you'll notice both of these have 3 terms. The first and the last terms are perfect squares. A squared is a perfect squared, B squared is a perfect squared. The middle term has a 2 in front of it because the square root of A squared is A, the square root of B squared is B. So A times B is AB. And what's AB plus AB? 2AB. So the middle term is always double the product of the square root of the first and the last term. We'll look through that a little bit more in the example that we're going to do. Actually, let's do the example right now. How about that? So let's pull the example from your worksheet practice. So our first example, let's do, it was 9a squared minus 24a and then plus 16. That was the working example from your worksheet practice. So let's just see if it is a perfect square trinomial, because if it is, the factoring is super easy. The hard part is figuring out whether or not it is actually a perfect square trinomial. So first thing, is it a trinomial? Does it have 3 terms? 1, 2, 3. Check 1. Yes, it does. Okay, is the first term a perfect square? Yeah, 9's a perfect square, so is a squared. So yes. Is the last term a perfect square? Yes, so it has 2 perfect squares. Now here's the deal. You have to check that middle term. So you're looking for is the middle term twice the product of the square roots of the first and the last term. So let's just see if that's actually true. Take the square root of the first term. What's the square root of 9a squared? 3a, okay? So that's 3a. Take the square root of the last term. What's the square root of 16? 4. Okay, ready? Here's what you're gonna do. You're gonna multiply 3a times 4 and double it. And if you do all of that and it equals 24a, then you know it's a perfect square trinomial. So let's see. What is 3a times 4? That's 12a, right? And 12a plus 12a is 24a. That shows us that this is indeed a perfect square trinomial. Now, if you remember from yesterday, because this is subtraction, that does change something slightly here. Let's go back over here and look at what happened. So a perfect square trinomial, again, 3 terms. The first and the last term are both perfect squares. The middle term is double the product of the square roots of the first and the last term. So when it's in this form, it is a perfect square trinomial. To factor it, here's all that you do. Ready? All you do is you take the square root of the first term and the square root of the last term. What's the square root of a squared? A. And what's the square root of b squared? B. Now let's set up our 2 binomials. That means my terms are going to be a and b, a and b. Kind of like how difference of 2 squares is. The first term is the square root of the first term. The second term is the square root of the last term. But here's the difference. There is a middle term here. It's not a 0 like our difference of 2 squares. So that means if this is a positive term, both of these are positive values. So whatever sign you see here, you're also going to see in your binomials. And then as we talked about yesterday, it's the same thing. A plus b times a plus b, that's just a plus b squared. Which it seems like that's a lot of work, but it's actually less work than trying to do one of the other factoring methods. How is this one different? Well, the only difference here is that the middle term is a negative, it's subtraction. So we do the same thing though. We set up our 2 binomials and we take the square root of the first term and the square root of the last term. The square root of a squared is a, so that means my first term is going to be a. The square root of the last term is b, because b times b is b squared. And because this is subtraction, both of these are negative, or in other words, subtraction. A minus b times a minus b, we can write that as a minus b squared. And that's all it takes. So let's come back over to our working example. We have already determined, yes, this is a perfect square trinomial. So the way that we factor it, it takes 2 steps. We're going to start by setting it up as a product of 2 binomials like we normally do. We already found the square root of the first term. We already did this work when we were determining that it was a perfect square trinomial. So I already know that the square root of 9a squared is 3a. So my first term in both binomials is 3a. The square root of the last term was 4 and 4. And then you look, what is the middle term? The middle term is negative, which means both of these have to be negative, or in other words, your binomials have to contain subtraction. What's 3a minus 4 times 3a minus 4? That's just 3a minus 4 squared. Now, did I have to do perfect square trinomial to factor this? No. I could have done slip and slide, I could have done double cross, but I don't know how many of you really feel like multiplying 9 by 16 and then trying to play P's and Q's. It just doesn't sound very fun. It kind of sounds, not really good, right? So instead, we have this method where we've identified that it's a special case and it actually takes us less time to factor in the end. So now we're going to go through some IXL examples. I'm going to keep the formulas up here or off to the side so that we can kind of use them to help us factor. And we'll try to go through as many examples as possible. Okay, we're going to spend the rest of this video going over examples from IXL code 56E. It's all about factoring expressions that are special cases. So you're only going to see expressions that are either difference of 2 squares or a perfect square trinomial. So I'm going to go ahead and share my screen here. So once you log into IXL, you're just going to plug 56E, factoring quadratics with special cases, and it's going to bring up our first example whenever my computer decides. Okay, so the first thing that I notice about this example, if I zoom in a little bit here, is that it is a trinomial. So that automatically takes out difference of 2 squares because it's 3 terms. So when I see that it's a trinomial, what I'm determining is the first term a perfect square, is the last term a perfect square, and is the middle term double the square roots of the first and the last. So I'm just going to do that check first, and then we'll come back. Let's see if I can make this a little bit bigger so that we can have them side by side. So I'm just going to do that check first. So is that actually true? So first example here, 16v squared minus 24v plus 9. Okay, first thing I noticed, 16v squared is a perfect square. That's a perfect square. 16 is a perfect square, v squared is a perfect square. 9 is also a perfect square. So really what I need to do is I need to test the middle term. So let's go ahead and look into that. So to test the middle term, once again, I'm going to take the square root of the first, the square root of the last, multiply them together, and double it or add them together and see if it gives us 24, which I think we kind of did this one already, but that's okay. So what is the square root of 16v squared? So what times what is 16? That's 4 times 4. And what times what is v squared? V times v. So the square root here is 4v. Now I take the square root of the last term. What's the square root of 9? We know that to be 3. So now to test the middle term, I multiply these together and double it. And if that gives me 24, then yay, this is a perfect square trinomial. So what is 4v times 3? Let's see. 4v times 3 is 12v, right? And what's 12v plus 12v? That's 24v. And look at that. That is the middle term. Even though it's subtraction, remember, we can deal with that later on. So this is a perfect square trinomial. Here's the cool part. Now that we know it's a perfect square trinomial, it takes 2 steps to factor. Step 1, product of 2 binomials. The first term is going to be the square root of the first term, which we already found. The square root of 16v squared is 4v. So this is 4v and 4v. The second term is going to be the square root of the last term. Square root of 9 is 3. 3 and 3. Now the question becomes, is it plus 3 or is it minus 3? Where do we look to figure that out? Ah, that's right. We look right here. Is the middle term positive or negative? In this case, the middle term is negative, which means both of these would have to be negative 12v's to get a negative 24. So that tells me that my expressions contain subtraction. So the first part is put it into your product of two binomials, 4v minus 3 times 4v minus 3. Well, we know 4v minus 3 times 4v minus 3 is just 4v minus 3 squared. All right, but there's only one way to see if we actually did that correctly. So let's see what IXL says. I'm going to write it as 4v minus 3. Let's see if it lets me do it. Squared. Is that what I got? 4v minus 3 squared, 4v minus 3 squared. Yay, and we got it right. Okay, on to our next one. Now, there's something different about this one, isn't there? The first thing that stands out to me is that it doesn't have 3 terms, it has 2 terms. So can this be a perfect square trinomial? Heck no, right? There's no way this is going to be a perfect square trinomial. We're testing to see if this is a difference of 2 squares. So check 1, is it a difference? Yep, it is a difference because it has subtraction. Does it have 2 terms? 1, 2, yes. Are both terms perfect squares? Well, I know 25 is a perfect square because that's 5 times 5. And f squared is a perfect square because that's f times f. Is 1 a perfect square? Yeah, 1 times 1. So if I write this one down, 25 f squared minus 1. This one's even easier to do than the perfect square trinomial because we already know that it is a difference, it has 2 terms, and both terms are perfect squares. So let's start by setting up our 2 binomials. We know our answer is going to be a product of 2 binomials. Okay? The first term in both binomials is going to be the square root of the first term. So what times what is 25? 5. And what times what is f squared? F. Okay, so the first term in both of our binomials is going to be 5f. Why? Because 5f times 5f is 25x squared. Then we take the square root of the second term. What times what is 1? 1 times 1 is 1. So that means my second term is 1. Because 1 times 1 is 1. Now remember, there's something different about the difference of 2 squares. One of these is positive and one of these is negative. Why is that? That's because there's no middle term. That means the middle term is 0. So the only way that you get a middle term of 0 is if you make one of them positive and one of them negative. So the answer that I came up with was 5f plus 1 times 5f minus 1. But there's only one way to be sure. Let's go ahead and plug it in. 5f plus 1 and 5f minus 1. Now, this doesn't matter. The order doesn't matter in terms of this could be minus, that could be plus, that part doesn't matter. Let's see if we got it right. And we did. Awesome. All right. So again, to do this IXL code, we're going to jump a level and do a couple more difficult problems, but you're really just checking. Is it a trinomial? If so, you're doing perfect square trinomial. Is it a binomial? Is it 2 terms? Is it a difference? Are they both perfect squares? If so, you're doing difference of 2 squares. So let's jump a level here and see what we got. Okay, this one looks a little bit more challenging, even though I'm pretty sure you guys would nail this one. So 25x squared minus 36. First thing that stands out to me is it only has 2 terms, which means it cannot be a perfect square trinomial. The only option is to determine if it is a difference of 2 squares. So start asking yourself, number 1, is it a difference? Number 2, does it have 2 terms? Number 3, are both terms perfect squares? If you're following along, the answer to each one of those questions is yes. It is a difference because it's minus. It does have 2 terms, and both terms are perfect squares. So here we go. Set up your two binomials. To find the first term, you take the square root of the first term. Oops, got ahead of myself. Haha. I'm already thinking about the next step. Get out of there. Okay. What is the square root of 25? That would be 5. And what's the square root of x squared? That would be x. So this is 5x. So the first term in both my binomials is 5x. Okay. Now let's take the square root of the second term. What's the square root of 36? What times what is 36? 5 times 5 is 25. 6 times 6 is 36. So the second term in both my binomials is 6. And then this is minus, so we make this minus and minus, right? Wrong, right? There is no middle term. So that means if this is minus, this has to be plus. Or if this is plus, this has to be minus. In the difference of two squares, what happens is that middle term is not there because it's 0. And the only way you can get 0 is by adding a positive and a negative opposite term. So our answer here is 5x minus 6 times 5x plus 6. Let's see if that's right. So we have 5x minus 6 times 5x plus 6. And we get our little good work there. All right. Ooh, here we go. Trinomial. So we're going to see if it's a perfect square trinomial. And at any point, if you want to try to pause the video and do this on your own, please do so. Okay, let's see. It is a trinomial. Check 1. Is the first term a perfect square? Yeah, 4 is a perfect square. Q squared is a perfect square. Is the last term a perfect square? Yeah, 9 is a perfect square. So now we just have to check the middle term. So I'm going to write this one out again. So we have 4q squared minus 12q plus 9. Okay, let's see if this is a perfect square trinomial, because if it is, it only takes 2 steps to factor. Alrighty, let's take the square root of the first term. So the square root of 4q squared. What times what is 4? 2. What times what is q squared? Q. So 2q is the square root of the first term. Now let's take the square root of the last term. What times what is 9? 3. All right, here's how we check the middle term. Ready? Multiply, add. You multiply them together, add them up, see if it equals 12. What's 2q times 3? That's 6q. And what's 6q plus 6q? 12q. And yes, that is our middle term. So what does that tell us? This is a perfect square trinomial. What does that mean? That means we get to use the shortcut. Yay, shortcut, right? Okay, so now it takes 2 steps. Step 1, set up your product of 2 binomials. Okay, square root of the first term is your first term, which again, the nice part is we already found it, right? The first term is going to be what times what is 4q squared. That's 2q. We already found that term. So it's going to be 2q and 2q. Then we find the square root of the last term. We already found it. What times what is 9? 3 and 3. Now here's the difference. We're not going to make one of them positive and one of them negative, because that would end up with a 0 middle term, and that would be a difference of 2 squares. We want the middle term to be negative 12. So how do we get negative 12? Do you think we get negative 12 by making both of these pluses and positives? I don't think so. This would be a negative 3 and a negative 3 to get that negative 12. And then our final answer can be written as 2q minus 3 squared. Why? Because multiplying something by itself basically means to square it. Now I'm going to try something on IXL. I'm going to see if IXL accepts this answer, this 2q minus 3 times 2q minus 3. Because if it does, then you don't actually have to do this last step. You could leave it like this. So I don't actually know what's going to happen here. Let's find out. Let's see. Instead of doing 2q minus 3 squared, Let's see if IXL accepts it. It would be really great if they did. Let's see, all right, drum roll. Oh, look, it does. So you don't even have to worry about doing the 2q minus 3 quantity squared. It's just, you could do 2q minus 3 times 2q minus 3. All right, oh, this is an interesting one because it doesn't have a leading coefficient. So for this one, you could also do p's and q's if you wanted to. What two numbers have a product of 25 and a sum of 10? So what times what is 25? How about 5 times 5? And does 5 plus 5 also equal 10? Absolutely. So look, we get to do this one super quick. 5 and 5. Because n times n is n squared, 5 times 5 is 25, and 5 plus 5 is 10. This actually is a difference of two squares. This is a perfect square, n squared. 25 is a perfect square. And 5 times n is 5n, and 5n plus 5n is 10n. So that one was actually easier than we thought, right? Okay, we're going to jump one more level here because right now we're only at a SMART score of 60, and we haven't really hit anything that's that challenging yet. So let's go ahead and jump all the way up to a SMART score of 72. Okay, okay, 49g squared minus 16. I'm going to do this one mentally because I feel like you're starting to get it. And I could be totally wrong because you're not in front of me right now, but I'm going to say that you're starting to get it. So let's see, is it a difference? Yes. Does it have two terms? Yes. Is the first term a perfect square? Yeah, 49 is a perfect square, and so is g squared. Is 16 a perfect square? Yeah, okay, ready? This is how simple this is going to be. I'm going to set up my two binomials. Okay, take the square root of the first term. What's the square root of 49? 7. What's the square root of g squared? G. That means 7g is the first term in both of my binomials. Okay, ready? What's the square root of 16? 4. Now, because this is a difference of two squares, notice there's no middle term. That means one of these is going to be positive 4. The other one's going to be negative 4. Oh my gosh, we just did that in like under a minute and we didn't even have to write anything else. Or anything down. Let's see if it looks right. Does 7g times 7g equal 49g squared? 7 times 7 is 49g. Yeah, okay. Does 4 times negative 4 equal negative 16? Yeah, let's see. Yay, it told us great job. Oh my gosh, what is this nasty thing? Okay, this one's gonna require a little bit of extra practice. I see, where are we at on a SMART score, by the way? Let's see. Okay, so we are at a SMART score of 75. And by the time we got to that SMART score of 75, we have this nasty looking thing. All right, let's work through this. 40, let's see. So it's a trinomial. We know that, 3 terms. And it looks like, I don't think 48 is a perfect square. And I definitely don't think 147 is a perfect square. Okay, this is a cool example. Ready? So once you get to a SMART score of 75, which now that I've seen this question, I'll make sure that we alter this scoring so that it makes it a little bit simpler for you. Okay, you know what this tells me? Because we're factoring with special cases specifically, this tells me there's most likely a GCF involved. Yeah, there's definitely most likely a GCF involved, meaning I bet you I could factor out a number from all 3 of these and make it into a perfect square trinomial. So let's see, what goes into 48? Well, what perfect square is a product or is a factor of 48? You know what I'm gonna do? I'm gonna bring up one of these bad boys. I'm gonna bring up a calculator, because why not, right? You have access to that. All right, let's see. We know 4 goes into 48. 48 divided by 4 is 12. Does 12 go into 147? I don't think so. Let's see. Ooh, how about this? I think 16 goes into 48. 16 is a perfect square. It goes into it 3 times. Okay, so that means to turn this into 16, which would be a perfect square, I have to see if both of these numbers are divisible by 3. Let's see. 168 divided by 3. Ooh, that works. Okay, fingers crossed. 147 divided by 3. 147 divided by, 147 divided by 3. Yes, and we ended up with another perfect square. Okay, I'm probably the only person excited right now, but that's pretty much normal. Okay. Oh, this is so cool. All right, this is gonna be really cool. I love ones like this, which means you probably don't love them as much as I do, but that's okay. All right, here we go. So we've got 48z squared. I'm just copying it down. You should too. Minus 168z plus 147. Now we determined that 3 goes into all 3 terms, right? We brought out our calculator and we determined that. So here's what we're gonna do. We're gonna factor out 3 from all 3 terms. What does that look like? Well, that means, remember, when you factor out a GCF, that means that number goes in front. So when I take 3 out, you're essentially dividing each term by 3. So you're going to be left with 3 terms, but they're all going to be reduced by 3. So I'm going to take my calculator out because I don't really feel like doing that type of division today, and that's perfectly normal. So 48 divided by 3 is 16. So that means my first term became 16z squared. Notice that the variable doesn't change because I haven't factored out a variable. I'm doing factoring out 3. Okay, now what happens when I factor out 3 from 168? So I'm doing 168, I don't know if you can see that, divided by 3, and I got 56. So this is still minus 56z. And then I'm doing, 147 divided by 3, and I get positive 49. Oh my gosh, people are like blowing me up right now. All right. So why did we just do that? Well, remember, our goal is to see if this is a perfect square trinomial. Is it 3 terms? Are the first and the last term perfect squares? And is that middle term double the product of the square roots of the first and the last term? So now that we have factored out the 3, what stands out to me is that 16 is a perfect square. So is 49. So we didn't start with a perfect square trinomial, ladies and gentlemen. 48 is not a perfect square. 147, definitely not a perfect square. So I just tried things. I was like, okay, what could I factor out to make it a perfect square? All right, here we go. Let's see. So now the 3, by the way, will not go away. It's still going to be there. I'll show you what I mean. Let's take the square root of the first term. So square root of 16z squared is 4z, because 4 times 4 is 16, and z times z is z squared. Square root of 49 is 7. So to test the middle term, we multiply these and we double it. We add them together. So 4z times 7, 4 times 7 is 28. So that's 28z. And 28z plus 28z, let's see, 8 plus 8 is 16. Carry the 1, 2, 4, 5, 56z. It is a perfect square trinomial. Crazy, right? Considering it's an IXL problem, so it's most likely a perfect square trinomial. Okay, so now here's the cool part. We get to factor it in 2 steps. Remember that 3 does not go away. So bring the 3 down. Bring it. It's still part of that product. Then open up your 2 binomials. All right, first term is the square root of the first term, 4z. 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 Second term is the square root of the last term, 7 and 7. How do we determine if it's adding or subtracting? Look at the middle term. Is the middle term positive or negative? It is indeed negative. That means our answer must be subtraction. Okay, how else could we write this? Could we leave it like this? Probably. Could we write it differently? Yeah. How about 3 times 4z minus 7 squared? That's all that you have to do, right? That's all. This means the same thing. Sorry, there's a cat outside, so I just got distracted. Okay, here we go. Let's see if that was correct. Otherwise, that would be embarrassing. Okay, here we go. So we have 3 times, I'm going to do the long way, 4z minus 7 times 4z minus 7. Is that what it was? All right, drum roll. Look at that. Okay. If once you jump up to a higher level, so we're going to go up to the challenge zone right now for those of you overachievers or, whoa, okay, crazy. So notice the only thing that changes here is that the numbers get bigger and bigger and bigger. So what does that tell me? That probably means that you're going to have to factor out a GCF at some point. But we didn't hit one of these questions until a SMART score of 75. And for this particular assignment, I'm only requiring, or I'm only asking you to go to a SMART score of 65. So a 65 would be a 7 out of 10, and that's a really good score if you want to go for that. If you want to keep trying problems that are more and more challenging, then that just means that you're probably going to have to factor out a GCF at some point. All right, hopefully that gives you enough examples to go through your IXL code. Again, IXL code for today is 56E. All of it has to do with special cases. So like hint, guys, it looks like this. All of your answers will look like either that or that or that. Okay, so email me with questions. We'll have a video conference later on, and I'm here to support you in any way. And as always, have fun factoring.